Hello. Hello. Wait, let me pull up this stuff. That is statistics. I already have some stuff written, but don't pay attention to that. I'm a bad cat boy. I already started doing the work. Hey everybody. How's it going? Hope it's going well. This music is so intense, but that's okay. I'm eepy. I went to my statistics office hours for like an hour and a half. Probably close to an hour, because I think I left, like... He just kept, like, doing problems and not, like, letting us ask questions, and I was like, no, this is not what I need. But, yeah, so I have a lot of these problems. This is due today. Reverse engineering someone's webhook to ping them constantly because they try to scam me. Oh my god. Be careful. That's not good, though. Don't scam people. What am I doing? I'm doing statics. You can see I'm doing statics. What was I saying? Oh, yeah, so I started doing these, this is due tonight, so I didn't, like, I have, like, 5 of these to do, so I was like, I should probably at least set them up before I stream, because the long part is, sometimes it's the setup, but, like, the approach, for some of these is, like, kind of hard, which is like this one. So, I don't know, I'm just gonna jump right into it. So, kind of... Actually, I think I can do this. Okay, so basically we want to figure out how to get shit out of here. That's the point. Basically, we want to like usually use moments to start out to like find some stuff, because right, if we like just look at the stuff in Y right now or like in X, we're not going to be able to solve that. Right, like if I look at all the k direction vectors, which is a, z, b, z, and w, I can't solve that. I don't know. I only know w. I mean, I can say a, z, and b, z are the same, but you found the Discord API webhook and you can send messages as their bot. They didn't encrypt it. That is so bad. That's so bad. Alright, so we have an industrial door, uniform rectangular panel, so our center of gravity is in the middle of it. That's what that tells us. Weighing thing, and it rolls along the fixed rail D on its hanger-mounted wheels A and B. Okay, so it's wheels. They're gonna push up, right, because it's a wheel. They're gonna be able to let the door move back and forth, but not side to side. So they're going to have a normal force on the side as well. The door is maintained in the vertical plane by floor-mounted guide roller C. So it bears against the bottom edge. That C is going to push against the door in that, like they said, the like bottom edge horizontal thrust kind of thing. For the position shown, compute the horizontal side thrust on each of the wheels A and B, which is what we kind of talked about, being in a slot, or like in a guide rail, and then which must be accounted for in the design of the brackets. Yeah. So the way I freed this body is A and B are where the wheels are, right here. So the wheels are here, but we're not looking at that. We're looking at the door. The door is our body. And I attached the brackets to the door, because they move with the door, but the wheels themselves, like, we're not really analyzing the forces on the wheels, because we're going to have the weight of the door and we're going to have this force, so it's going to be acting against the door. So that's why I did that. And I came up with 5 unknowns with all that stuff. 1, 2, 3, 4, 5, and then we know the weight. So we want to get AX and BX, and we also want to get... we don't care about anything else. So, I set it up to ping the owner, then delete the message every so minutes. That's crazy. Probably want to take a moment. I'm thinking, hear me out. I'm thinking we take the moment about the line AB. That's the line here. Because if we take the moment about AB, we'll have weight, right? Because it's a certain distance away from this. And it's like 6 inches. And then C. And those are only our two things, and we know weight, so this will give us C. This is our strategy. I should say strat. I'm gonna say stat det also. Stat det, because we have 5 and we can probably write 6 equations. I mean, it's kind of dumb to say that, but you know, we don't have like 7 variables, right? So MAB equals 0, that's gonna give us C. And then if we have C, we can say stuff about AZ and BZ. I just put a bottle of water on my shirt by accident. Oh, rip. Oh my gosh, Cosmo. How's it going? It's been so long since last I've seen my son lost to this monster, the man behind the slaughter. What's up? How's it going? I was thinking FY, because then we could do like, you know, you get AZ related to BZ. I just draw this like kissing mouth. Why do you care so much about follow time? Cosmo's my friend. Cosmo's a Starfy. My beloved Starfies forever. We can get AZ related to BZ, and we can also get AX related to B. Oh wait, no, I lied. If I just wrote the dumbest thing ever. Okay, I wrote FY and then I wrote Z. No, I want to say FX, and then we can get AX related to BX. Whoopsies. I am expecting this one to be bigger, because like, if it's pushing here, this one has to resist more this way. I'm just curious. That's fair, I guess. I guess I could do FZ, and that would give us like AZ relationship with BZ, but I'm still stuck is the issue. I don't like it. There's gotta be somewhere else. I could take the moment about oh my god, for real. I've been good. I have math homework to do, which is insane because now I have homework for the first time. Mind blown. You never had homework in homeschool? I would love to take the moment about this plane. Sorry. You're doing art for your eventual VTubing hobby? Wait, that's awesome. Slay, another VTuber. Me looking at my 2.0 rig that I haven't finished yet. He looks so cool. I want to finish him. Oh, PNG tuber? Swag. That's how I started out. Because it was easier. Actually, I started out as a GIF. I didn't even talk on stream for a while. For now. Oh, ... Well, Live 2D trial has like a free trial for a month. Or you could just use free version. If you have never rigged before, free version is probably fine. Your homeschool was a bit, well, Smiles a little bit odd and strange. Bad even. That is true. I understand that. You're so educated now. That's awesome. I hope it's going well. Are you like dying because of like the Switch? I was educated before. If I take the moment about like here, this shit goes away. Oh, if I take the moment about here, this shit goes away. And I can get BX to BZ. And then I don't know if that's right. Is that right? I can get BX to BZ. Then I can put AX in here. And then I think I could get A, because like AX and AZ are related to A by the cosine, but I don't have a cosine. I'm dying a bit, it is true, but I'm pulling through. Ulului. What does it say? Ulului? I don't know what that means. Okay, I I like moment about AB. If you have a variable in an equation that could be anything, just remove it because it can be 0 as well. No, is the thing. Well, none of these are 0. If they were 0, that would be bad. It'd be bad if they were 0. Because all these have to be here for the thing to... Like, they're either here... well, all of these are here because they're physical forces. So, like, it kind of like how if you put a thing on a ground, there's going to be a normal force here. And if there wasn't a normal force here, then it would fall through the ground. Or gravity doesn't exist. Which it does exist. So these are all here for that reason. But I'm just trying to think. Math teacher's kind of evil and mean at times, but it's okay, I'm adapting. Unfortunately, math teachers are kind of ass almost all the time. Yeah. But, you know, I don't blame them. It's a hard thing. Society doesn't really make it super easy for them. What the hell am I doing here? Okay, let me think. Okay, let me just think about all the places I can take a moment about. I can take a moment about here. About the centroid. The center of mass. That would just give me so much shit. That's too much shit. I gotta get rid of some of the shit. If I took a moment about here, that would get rid of those two. Well, I guess I would have to take a moment about here. Specifically. Or a moment about here? I took a moment about there. Ooh. Oh, maybe that's the trick. Because AX and C go away. And you just get AZ and BZ and W. Fuck, no, you still get AZ and BZ and W. Wait, but if I use AZ and BZ and W, and I have FZ as well, maybe I can use those two. It's actually very sweet, but oh my gosh, my class teacher's so garbo, so I understand. Yeah. Yeah, that's like the biggest thing. I think it was from a guy who said, if you can do anything, just do nothing, because with no goal, it's the action that requires the least effort. Well, that is true, in the sense that, like, kind of, I don't know, the normal state of the universe is to want to get rid of all energy and do nothing all the time. And also trend to be farther away from things. That's entropy, baby. But, okay, I want to take the moment about B. I want to take the moment about B. Wait. Oh, AZ still happens. Moment about B, like, can I say, like, B? I don't know. B1. I'm a B1. Is it great notation? No, it's not. It's not great notation. Well, okay, let's just say this. And if that gets us somewhere... I have no goal, so my goal is to find a goal. I have a goal, my goal is completed, repeat. Oh, that's like a paradox. Let's just do moment about AB equals 0. That's actually going to get us some shit. Thank God. Okay, so what does that mean? Moment about AB equals 0. So where's AB? AB is this line here. So we want to say, okay. I need to do a convention here. I'm going to say that this way is positive. We're just going to say that's positive. I'm just going to go along the positive J direction. Yeah, it's kind of scuffed, but we'll just say that. So that's the positive J direction, so that's going to be a positive rotation. So for the weight, it's pulling the other way, so it's going to be minus the moment of the weight. Why am I doing this with scalars? I guess I could do it with scalars. I mean, this part at least. And then C. Oh god, which way does C? Okay, C is going to be positive. That's good. That's good, actually. Because then we know they're going to be equal. That's true. That's true. That's good. Okay, so moment weight equals moment C. Okay, scalar directions here. So the perpendicular distance between these two is 6. Hi, Umbra. How's it going? So, this is 6 inches times 120 pounds equals, we don't know what it is, but how far is it away? It is the vertical distance, which is 10 inches. 10 inches times c. So that's going to be 120 times 6. So c equals, what's 120 times 6? I don't know, off the top of my head. 720. Okay, that's what c is. Let me see. Get it? That was a okay. He did do selected answers for these, so if he like tells me C and I got C right, then like we know we're kind of on the right path. I don't know what the selected answer for this problem is though. It might be like, this is the tension. Oh, there's no tension. FAX. Okay, I don't have AX. Okay. Well, we have something. We have something. What if I took the moment about C? No, that would be stupid. Whoa. Whoa, let me see. I have a goal. I can break it into sub-goals, each one more digestible and completable in a reasonable amount of time, and each I can take a break and regain motivation as well as not rather move on to the next goal. So why don't I want to continue after the first sub-goal? I think part of that is like what's the word? Like, Damie be like, does math, x d d d d. Yeah. Gets very tired. Okay, I like this one. I don't know if I like the FC. If I do the moment about this, all this and this and this and this are gonna affect it. This won't affect it, which is like the worst thing I could choose. I want the weight to affect it. If I want the weight to affect it, I gotta pick something where the weight is. Wait, no, the weight would affect it. What am I talking about? If it was the moment about like C to C1 or something, then wouldn't literally everything affect it? Yeah, because there's no, that would be the worst. That's just unsentences. Damie be like sentences. C's chat me. Just reads it. Unsentences. I was gonna say, what's the word? Like self-determination, not that. Like self-motivation. It's not self-control, but it's like self-control. But like the thing that like you do when when you like, you know what I'm talking about? You know what I'm talking about. You know what I'm talking about. I'm just gotten dumber the more engineering I do. I'm like, you know what words are. Okay, I want something. It's gotta be either in the. It's gotta be a line going through the I direction, because it takes out. But no, I want the stuff in the C. Ooh. Wait, no, it needs to be going in the K direction. No, but that's not even that good either. Wait, no. Wait, yes. The moment about A, Z. Yes. Because that gets rid of this, that gets rid of this, that gets rid of this, that leaves this, that gets rid of this. So C is B. Let's go, baby. Let's go. Oh my god, that took like a... It's not good that that took me that long, but it's also okay because I haven't done all these problems yet. This will give us... BX. And then if we do moment about BZ, that gives us AX. Well, then I have to figure out how to get BZ. Thing where you get demotivated and you slap yourself in the face and say continue. I need to look up this word. Like, what is the word for when you can force yourself to do things? Grudgingly? No, that's not what I'm talking about. Diligent? No. Discipline. Self-discipline. That's the word. I feel like that's also not the word. It's kind of the word. Damien be like, math is great, so is my lawyers have advised me not to continue this joke. What were you? Wait, what? So is... Oh, I see. I see the joke. I see the joke. I was like, because in my brain, like, Met just auto-completes to, like, Metropolitan Museum of Art. New York, Catboy. New York. I was like, what? Why would that be bad? Okay, this equation sucks. I don't like this. Wait, but then I can just do, well, I don't even need to do this. I could just do sum of forces in... Why even bother? Just do sum of forces in Z. Oh no, just do... This is... All of them are bad. Hey, I'm walking here. Forcing yourself to do something you don't really want to do achieves bad results? Depends. Because you kind of have two options, and I feel like this actually is very applicable to engineering, because a lot of people... How hot of a take am I ready to give? Okay, a lot of people don't like a lot of engineering. People don't like doing statics. People don't like doing drafting. People don't like doing detailed drawings. I do. I like all of them. I like all those things because I think they're fun, they're engaging, to me. But if you can motivate yourself to do it, and you don't necessarily have to like doing it, but if you can figure out a way that, like, motivates you, a lot of people do that, is the thing, and it works. So it's maybe not necessarily, like, whether or not I get possessed by a demon every so often. Yeah, that just happens. I actually don't know why that happens. Sometimes people say it's interference. I have no devices that could interfere with that. You gotta see it pretty... I need to get blessed. It's not still going. I can see my audio meter. Unless it's going, and then it's a bad thing. Anyway, sorry about that. I've tried so many things. I don't know if it's the cable. I don't know if it's... Just add pi. Just add pi. In the background, when I speak, it could also be my computer fan. Probably my laptop. It could be my laptop. I thought it was a power issue thing, like it was just overloading. I thought I had my noise cancellation on though. It's a little echoey in my room, which is kind of annoying. I wanted to fix that. That's what your fans... I literally am on a laptop. I stream on a laptop, so that's why. That's why my fan sounds like that. It's just really, like, high-pitched. Wait, let me see if I can turn on my... I think I turned it off because it was cutting off part of my range. Let's see. No, it's on. It's just... I didn't... A lot of reduction. Do one of those audio tests? Yeah, I'll figure it out. Okay, the thing is, like, as an engineer, I don't have time to do anything. I turned on my noise cancellation. Unfortunately, yeah, I don't have time to do anything ever, except for eat and sleep and poopy. And lion dance. I do lion dance. A lot. Okay, okay, all the moments about the z-axis. So we get rid of C. We get rid of... Did we get rid of C? We don't get rid of C. No. Wait, it's okay. I lied. We know what C is. Who cares? Okay, the distance between C, that's 2 inches. sorry, I need to figure out direction. This is positive. That's positive. You should just use the positive to be the positive of the axis, but it's good to just mention it. Okay, so C, that's going to be positive. So positive moment. C, we did not already calculate it. I lied. W goes away. And then BX is the opposite direction, so that's minus. Oh, it's so beautiful. Guys, it's so beautiful. I love statics. Okay, so moment C, that's 2 inches times 720 pounds. 2 inches pounds equals, and then our B, how far is our B away? I'm just using scalars because, like, why not? Who care? 10 inches. They give me a lot of scalars, so. BX. Oh my god, it's the same thing. What's 2 times 72? 2 times... Wait! Wait, 144. Okay, wait, that's good. We don't need to find BY. I just remembered. This is great, guys. I need to do less work. Who cares about finding BZ? I don't care about finding BZ. I mean, I don't care about finding anything else. Me when I have to say what 1 plus 1 is. Me when I have to prove it. Oh no. This music is so appropriate for this point. I need to put on my, like, edited version of my music for this game because I can't live with just the scary ghost music. My mouse is so not working lately, but it's whatever. I had to, like, use my school's mouse working on SolidWorks, and I plugged it into my computer, and I was like, this just feels wrong. Like, when you don't use your mouse on your computer, it's like, ugh, you know? But I mean, at least it worked. My mouse sometimes doesn't click and stuff. Okay, so then we'll just do the moment about BZ. This is great. Oh my god. Okay. So that gets rid of so many things. Wait, did I say yeah, about B1, I really should say. It doesn't really... Yeah, no, it does actually matter. It should be A1 and B1. Actually pretty important, because otherwise it gets rid of those vectors. What was I doing? Okay, we'll use the same positive convention. And then I'm really praying that this is what it is. Okay, so C is going to make this rotate negatively this time. And AX is going to make it rotate in the positive direction. I don't need to write that. Equals 0. My handwriting is kind of ass right now, I don't know why. My dad equals invisible squared. Oh no. If you square infinity, it's still infinity. Unfortunately. Okay, the distance that C is away from B is, let's see, so this is 2, so 8. JK! Teehee, JK. Honestly, the scalar approach to this is kind of awesome. Wait, why did I... Oh, AX. Like, this is kind of really simple. My professor had us do, like, 14 cross products. I'm not about that. Okay. 72 times 8? I don't think that's right, is the issue. It's 5... Where did I get 576? Oh no. Oh no, I must have done something horribly wrong. It's supposed to be like 48. Ooh, that's not right. No, ooh, that's, unfortunate. I think the answer is supposed to be 48. Yeah, it's 48. How do you... What the hell? Well, see, the thing is, like, it seems right. This seems right. 2 times 72? Can already imagine a cowboy getting his master's degree? Oh my god. Hey, if it pays me more money, I'm down. Why would A be taking more of that moment? No, that shouldn't be right. A is... What? Huh? This is weird. A is further away. I turned into wind, sorry. What is up with this? Is my moment about wait, let's see, moment about A, B. I meant to ask, how have you been? I've been well. I've been pretty good. Except, like, I've just been really busy. Wait, I'm trying to, like, contort my hand. Wait a second. Oh no, I goofed it. Wait, no I didn't. Oh, oh, wait. Wait. No, I didn't goof it. What did I do? Because I was trying to figure out my perpendicular distances, and I was like, oh no, I didn't say that C was 6 inches away from the wall, but it doesn't really matter, because it's like we're... Wait. It does matter. Wait, the perpendicular distance from C to AB... Oh no, it's 10 feet? Wait. Oh my god, they are in feet and one's in inches! It's 10 feet and 6 inches! No wonder my answers are so high! That's 10 feet! That's 10 feet! Not 10 inches! Of course it would be like £1,000,000 pounds if it was 10 inches! Oh no! Oh no! Whoopsies! This is 60! That makes a lot more sense! Oh my god. 10 inches! I just cannot believe that. What a good issue to have. What a great issue to have. 2 times 6, 12. That seems more right, huh? 720. 8 times 6, 48. Gamers, we're back in business. I love life so much. This is awesome. I'm so good at it. Damie, when he gets one statics problem right in 34 minutes. It only took me 34 minutes, guys. Don't worry. That means 4 problems is perfect. This one I think I actually got right, though. This one I think I actually got right, like I set it up. Okay, that makes me so happy. I got it right. Yippee! And like, oh, yes! Yes! Okay, sorry. Oh, it's so nice when I don't have to like go through and like try and figure out all the... It's like this one. We were building this part today in my SolidWorks assembly class. And it was like this. It didn't look like this. It kind of looked like this. And there were these holes here, these tapered holes, or tapped holes. Tapered, lol. There's tapped holes, right? So they look like this. And there were so many holes. There were like 3 holes back here, and there was another one like over here. And there, or sorry, it like went through the front. It was like through there. There was one on the top that was like a counterbore, and I was like, my volume is wrong. Where is it wrong? And I was going through everything, and I finally was just like, I need to ask somebody. So I asked the TA, and he was like, wait, turn your part around. And I was like, I've been looking for like 20 minutes, like where I was just like checking all my dimensions. I was like, fuck, it was like 1 centimeter cubed off, or inch cubed off, and it was because I put a countersink on these holes, because SolidWorks automatically puts a countersink on your holes. Engineering, man. I made a mistake? No, I didn't. I got it right. Winning forever. Okay. Let's see. This one is a lot easier, because it's just a beam. It's just a line. I don't know if this is like a crazy, like... This free body diagram is me. Damie never makes mistakes. He's perfect. Thank you. I do make a lot of mistakes. Hours and hours of mistakes that you can see. But we're gonna pretend that I don't. I still have to do stats after this. Okay, I like understand stats better than I did the last time I streamed stats, which was like 2 days ago. Like, now I know, oh, you gotta draw the X, and then it's like this, and then it's like this, and then you do this, and then you do, oh, it's 0.6, and you go, oh, yeah, do 0.3 times 2, and then z equals 1, and yeah. Stats is actually kind of cool. I'm kind of coming around to it a little bit. It does feel like, the best way I can describe it is like, I'm like a math guy, right? Like, or, well, I'm an engineering guy, but like, it feels like math is like the chaotic, like, good of like wizardry, where it's like, ah, yes, I know how to like do spells and things. And then stats is like the crazy unhinged, like, warlock with like the giant beard and like the cauldron and just like throwing random shit in there. And it just like making like potions and like, you know, that's what stats feels like. Like the fact that you can take two, okay, maybe not 2 measurements, you can take like 3 measurements, and that you can just like take 3 measurements of something and you can estimate a standard deviation that's like pretty close to a real standard deviation if you took like, let's say 300 measurements. I say pretty close in the fact that like it's 3 measurements, like 300 measurements. That's crazy. That's crazy. That's actually crazy magic. Anyway. If anyone is a stats major, you amaze me. You guys are crazy. I respect it. I respect the grind. You guys know numbers way better than I do. Alright, let's see. So, stats and sigma both start with S, true. And also, S is the standard deviation for a sample. Things that I have to unfortunately remember. Okay, so we have an I-beam, it's got a mass, cool, so we gotta have its weight in there, which I have in the free body. Determine the tension in the 2 supporting cables, so we got 2 cables. We can get their angles, because they're at triangles, so they're both 1 unknown instead of 2 unknowns. And then we have a normal force at D. So this is low-key not... There's only 3 equations. Wait, why did I write 5 equations? I was kind of lying for that. There's 3 equations here, because they're not all parallel forces, but like, it's 3, because once we figure out one of the components of like TB or TC, like, I'm just gonna say TB and TC. Yeah, we're chilling, basically, is the... So I said, if you do the moment about AZ, so moment about A in the Z direction, you can... It's kind of a weird thing to do, I guess, but like... Wait, why did I say that? Wait, that literally gives me nothing. I should not have said that. Well, what was I thinking? I want to do like moment about A in any other direction. That is not right. Okay, maybe I wasn't cooking. Don't look at me. What was I thinking? Let's see. What can I do? I could do moment about A in the... I don't really want to do moment about A in the, like, Y direction or anything. Oh, wait. Yeah. I can do any other axis, because both of those start from A, so they'll go away. They don't have any perpendicular distance. So, should we do I or should we do J? Should we do X or Y? I feel like X. X is chill. No. We have to do it about Y. I lied. Because otherwise they're not rotating it. Whoopsies. Okay, but that'll give us ND. I don't know why I called it ND. Normal force at D. And then if you do Fy, you get TC's relationship to TB, and oh. Oh, there's a bot in chat. Goodbye, bot. I have to move over to this one to get my mod controls. Where's my mod controls? Chat settings, show mod icons. Oh, I don't want to ban them. Get out of here. Be gone. Oh, sorry, I deleted one of Egg's messages. Go back. I'm sorry. I deleted one of your messages. No, it's still here. I must hate comp. Davey has an M in mistake maker. Engineer has an M in it if you spell it wrong enough. Big brain, big brain. I'm sorry, Egg. I double clicked with my mouse. Okay, solve. That is a bad way of writing that. There we go. MAY equals 0, so that's going to be, alright. We're going to say that the positive direction is going to be this way. Imagine double clicking on the finish button and on an online exam an accident before you're done. Oh, I would die. I would die. I feel like I've done that at least once. I feel like a lot of people have. Not like a final or anything. Then again, I haven't taken any finals online. That's a lie. I've taken one final online, my welding final. And I took my welding midterm on stream. Probably not allowed, but it's okay. That was kind of a goofy midterm. Anyway, I pray for your soul for all the times you've made that mistake. Oh god, yeah, that would be really unfortunate. Okay, so ND, moment about ND, is going to be positive minus moment about the weight, right? Because, wait, fuck. Wait. Oh. Huh? Oh, this is a conundrum. No, I'm goofing it, because it's like that one is over there. That one's positive, that one's... Oh, no, okay. I'm not goofing it. This is right. I was like really confused for a second there. I think I should check... No, I shouldn't put vectors because these are scalars. We're just doing scalars. Thank God. Okay. He would probably yell at me. Well, not yell at me. I would just get points taken off. Better or worse? I don't know. M and D equals MW. So we'll do MW... I'll write it the other way. MW equals M and D. Okay, so MW, the distance, perpendicular distance is, well, great question. So 2 plus 5 plus 1 is 8, so 4. I'll put, I don't really like putting dimensions on my free body diagrams. I know a lot of people do it. I think it's a good thing to do. I think it clutters my thoughts a lot, and so I don't like putting them on it, but this is 2. Ooh, ah. Old man noise. Okay. Okay, so the distance between them should be 2. 2 meters times, and then mass of 60 kilograms equals, and how far is this away? This is at 1 meter away. Let's see, D to A is just 5 meters, so 5 meters times M and D. Is So 24. Is that right? 5, that, 2, yeah. kg meter, which is just kg meter. Nothing I can do about that. Okay, and then we'll do... I still feel kind of weird about doing Fy. Wait, I don't even... Wait, I don't even need to do that, do I? Wait, yes I do. Wait. Actually... I don't think I need to do fx. Maybe I do. Yes, I think I do. Let me do fx first. Because so fx equals 0 is going to give me, right, tb minus tb plus tc equals 0. So tb x. I mean y. Whoopsies. tby equals tbx. tcy. Wow. tby equals tcy. So that means that tb... Sine or cosine? Well, let's see. If we're talking about this angle, I guess it doesn't really matter which angle, because we'd probably be talking about this angle. So if we're talking about that angle, that'll be what? Sine? No. We're doing y. It would be sine. Yes. Sine 2, 3. Okay, I need to do a little bit of work. That, and then 2, and that's 3. So 4 plus 9, which is square root of 13. Is that right? That sounds right. Sine of, well, I mean, I guess I could just do it. I don't even think I need to do it, because it's a sine of the same angle. TB sine phi equals TC sine phi. TB equals TC. Right? Like, this is phi. This is also phi. They're the same triangle, so. And then we can use this to do fx. Nope. God damn it. Wait. FZ. Jesus Christ. I don't know why I keep wanting to misname things. Okay. So, yeah, 2 times TC, essentially. Minus, so 2T, or so TB equals, oh my god, equals TB plus TC minus weight plus NB. Oh, and then we just have to do this. So it equals 2TC. So that'll be W minus NB equals, what is that, 60 minus 24? So, oh god, can I do this in my head? Let's see, 40 minus 4 is 36, so 36 over 2. Can I count to 100,000 in binary? Oh dear god. I don't even know if I could say 100,000 in binary. What is that? I don't know my powers of 2 well enough. Converting to binary is kind of a slog. I don't think I could do that. What is this, 18? 18? 18 AGM equals TC TB. Please tell me that's right. Let's see if I get anything right. 1.89 kilonewtons? Hello? What is happening? That is not what I got at all. What? 1.89 kilonewtons? Yeah, oh. Oh. Oh, you mean like 1,000,000? What is that in binary? Let's see, 1. That's 2, 4, 16. Nope. 8, 16, 32, 64. You just mean, can I count to 64? Yes. Is that right? From binary to base 10. Oh, I goofed it. It's 32 even. Oh, because this is 2 to the, this is 1, 2, 4, 8. I remember. I can count to 32. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 32. Okay, I'm gonna come back to this one because whoopsies, something is wrong there. Very wrong. Don't know where that comes from. Also, kilonewtons? That seems goofed. Where are we getting kilonewtons from? I mean, I guess kg. We should not be getting kilonewtons, I feel like. Because newtons are kg per meter squared. Oh, whatever. Okay. I gave up. I think I gave up here. Oh, no, I didn't. This is correct. This one is actually very straightforward. We want to take B, the moment of B around X. Because it'll get rid of everything except for, we'll have to split our force. Wait, what the? That real? That is not, wait, that's not the right equation. We need to get rid of TC, but we also need it to go through. Wait, can you think of a prudent moment about an arbitrary axis equation? Moment about an arbitrary axis equation. Please count now. I did. 1, 2, 3, 4, 5, 6, 7, you know. Where you could compute T1 without computing T2 or the forces at B. Wait, what am I? No, that's not it. I was going to say, what am I talking about? Just do moment about AB. But that would also get rid of TD. Could I just do, like, at A? No. I mean, at B? No. Well, this is incorrect. This one is definitely incorrect. Because if I did the moment about this, your force, these two act. You can't get that. Let's see. I don't want T2. Ooh. Ooh. What about this? What about moment about BC? How do you feel about that, chat? How do you feel about moment about BC? I'm kind of vibing with moment about BC. That gets T. That gets rid of. Gets rid of B. I think that's our play. Yeah, let's do it. Moment about BC. My left kidney is missing. For a moment of EP. Egg priority. Moment about egg. This is what I imagine egg as. And then just like rotated. rotate you. Spell of rotate you. BC equals 0 would give us TD. Because it gets rid of all the shit we don't want. Alright. Then we just gotta do it. MBC. I love it when equations are just like one thing. God, it's beautiful. I don't have to solve any systems. If I can do that for everything ever, until I get into finite element analysis, then that's gonna kick my ass. Okay, this is not, well, I mean, it's gonna equal 0, but I guess I might as well write out stuff. So, about BC, let's say that, okay, unfortunately, we have to compute the moment about something else, and then Yo Banana Boy is a palindrome. Yo Banana Boy. Yeah, you're true. That's correct. Yawning. Okay, so we need to do R. Oh, God. No, I'll do this. So moment of TD. Which way is it gonna rotate it? We're not doing this with scalars. Plus, this with vectors. Plus moment about F. This is vectoring it up. So this is gonna be R we go from this. We're gonna go, I guess, here, from B to TD. Now, is it where TD starts? I think so. Yeah. So R from B to A, cross force TD, plus R from B to F, or B to M, cross force F. It's a weird, that's bad. I'm just gonna say cross F. That's right. Okay, we do have to do some cross products. I have to make some vectors first. Okay. R from B to A. This is great because they actually give it to us. So from B to A, we're gonna go, that's gonna be positive Y. So that's 3J plus 10K. And then R, B to M. Also they give to us, this is good, because they give us this stuff, so like it's more likely that it's right. 1.5J plus 5K. And it's so nice, it's just 1/2. FTD, we do have to make that as well. That's going to be a little bit harder. We're going to normalize it and multiply it, so this will be like FTD times. Okay, so we have -4I minus 2J minus 10K. And that's going to be over plus 100. It's normalized, and then we'll do our F as well. Oh, they gave us a, it's fine. 20 kilonewtons times, we'll just do cosine 20I plus sine 20J. Nice, so we have all our formulated stuff. Now we just chuck these bad boys into cross products, and we let the computer do it. Except that isn't really how it works, unfortunately. I guess I should probably just get Symbolab up or something. Does Desmos do it? Probably not. 3, 10, 0. That's wrong. 0, 3, 10. And then cross F, so FTD. Haha. Anybody know the square root of 120 off the top of your head? I don't. Let's just say 4 divided by the square root of 120 minus 2 divided by the square root of 120 minus 10 divided by the square root of 120. And then plus... I can pull out this, and then we do I, J, K. 0, 1.55. Cosine 20, sine 20, 0. Okay, and then we just have to solve for everything. Equals 0. Don't forget that. Where do I want to solve this? We'll do Symbolab. Like, it's okay. So, like, Symbolab matrix. Symbolab determinant calculator. Can a determinant calculator sponsor me, please? Someone? Anyone? The text in this is also a palindrome. Sun-obsessed dog goddesses. Bonus! That's so fun. My mouse click. Okay, I'm just gonna put IJK. We'll see if this works. If it doesn't, somebody panic. No, it's okay. Then I'll just find a different thing to put it in. Okay, and then -4 over square root of 120. I probably should just figure out the square root of 120. This number, it's big. I don't really care what it is. Why is Google not letting me copy this? Ah, because I'm not actually clicking. My mouse is goofed. 4, and then what was the other one? -2? -10. Okay. Go, my Symbolab. Hell yeah. It actually gave me a solution. So this one is FTD times -3 we're just gonna use... Oh, that's J, I guess. I don't know why I put J first. That's kind of weird. Plus 1.09. Nathan is a palindrome if you use th for th. Nathan. I like that. I think people should start naming their kids that. 0.91. And then we have to do this one. I don't actually know... Like, how am I supposed to do this? Oh, no, I do know how to do it. It's just... kind of dumb. It's 3 equations smooshed into one. Which I guess is true, because we don't... No, we do know the angle that it's at. Odd. Okay. Well, because, like, I could just add all these... Oh, I could have just added all these together. And then I wouldn't have to do 2 different equations. Does that work? I guess it does, because you multiply 20 into these 2, and it still works. And then I could have been like 0, 0, that plus whatever. Let's see, 0, 1.5. And then cosine of 20. Making me do his old number. I don't actually know if it's going to pick up on the fact that that is a cos 20. We'll see. It's going to be like, sine 20. No, I got it. Okay. (2.04 J minus 0.61k minus. If this has led me astray, if Symbol Lab calculates these wrong, I'm gonna be so pissed. So F. Oh, let's say like the I components. Equals, right, 2.04 over 3.65. Nope, that's the, not that. That's the J components. I don't know why I did that first. Because that's the order they're written in. So who care? This one is... Oh, I didn't actually multiply this by 20. Whoopsies. 20 kilonewtons. It's okay. I can just multiply each one of these individually by 20 kilonewtons. It's a little scuffed. It's a little scuffed. It's a little scuffed. 0.61 over 1.09. Oh. Did I goof some? This one is T from A to D. A, you go down, back, and over. They should all be negative. Huh. What about my force? My force should be positive. And zero. Huh. Well, I don't know. Whatever. I'm not going to think about it too much. I probably should, but, whatever. Let's see. Yeah, because that would give me a negative number. I mean, I guess it doesn't really matter because it doesn't. Because we're doing magnitudes, right? So this is like all direction. Do I want to... I don't want to get out my calculator. I'm lazy. Damie hype. Thank you. My biggest hype person. Um, 11.17. 18 kilonewtons. And then 1.09. Wait, uh-oh, that also... Hydrate, thank you. Wait, 11, I have water this time. Okay, drink water, bye. I love that our bit is just drink water. That's the whole bit. There's no more to it. Okay, this one gives me more, right? 100! Oh wait, no, that makes sense. Wait, not in the I direction. Fuck, what is wrong with this? Why is that in the I direction? That shouldn't be in the I direction. I don't like that that's in the I direction. The other two make sense, but if I think they like switch the axis or something. Let me see. Let me see. Let's see these selected answers. I don't know what it is. I do not know. I do not know what that is. If anyone is an audio engineer. It's like I'm haunted. It's literally like I'm haunted. I don't know how to fix it. I like changed cables. I changed power banks. I plugged my mic directly into my computer and still did that also. I don't know if it's a software thing. Okay, wait, it actually could be a software thing. Wait, I didn't update that on my computer after I moved. Wait a second, wait a second. Wait, where's the software for it? Report a problem. Details. My mic explodes with white noise. Include relative product information. I need to flip it. I need to flip it. I need to flip it. Where's the options? There we go. That might fix it. It might make it worse. Who knows? I don't know. I need to solve for T2 as well. No, I don't want to do that. I just solved for T. Oh, wait. I didn't project it onto the AC. In my hubris, I forgot about the triple cross product. I'm not doing this right now. We're not doing that again. That's not happening. I have to do a triple cross product. Sigh. I have to do a triple cross product. I don't want to do that. We'll just do this one. This one's not a triple cross product. This one's a normal problem. Oh, actually, this one is very hard. I don't know how to do this one. I think set it up right, though. But, okay, calculate the force P min required to initiate rotation about the hinge axis BC. For the first time, I've been stumped completely. I've been stumped completely many times before. It's just I don't want to plug it into my calculator. I'm not even stumped. I'm just the math one. The math one today. I guess I just take my initial reaction. Take the moment about BC, but that's like not really that good. I'm in my mother's womb right now. A little spacious. You're the first real iPad baby. You are the iPad. P and D, like I can't do P and D here. I was trying to think of like, because I have 6 unknowns. 1, 2, 3, 4, 5, 6. But like, I don't know. I was trying to maybe think if I could do BC. Because they would get rid of all those, the bearing forces. We want these. I mean, we kind of want all of them. But, ow, slammed my ball. Yeah, this one is stumping me a little bit, because like I could do. It seems like the most obvious thing to do is to like maybe have D equals 0, or because like it says calculate force P hinge required to initiate rotation of the hinge axis BC. If you require rotation, it's like right when you have no normal force, because like you're pulling it up off of the thing. I'm gonna say that, I think. Let me see. I'm gonna say D equals 0 for P min. I think it might be that. Because then, like, this, you can plug in P, because then you can do a moment about this, and you just have 2 unknowns in that. That's what I think it is. Let's do that. So moment about BC equals 0 equals, so we're going to say that in the positive I direction, it's, so this is positive. So that'll be P is positive, moment P minus moment S equals 0. Right, because S is rotating it the other way. So moment P equals moment S. And then we have, I'm going to just do distances because they give us these distances. So we'll say 135 millimeters times P equals, and S perpendicular distance from this is this distance right here, 45 millimeters. I think scalars are really the way to go for this. Oh, I need to calculate a spring force? That's kind of rude. Fs equals what? Kx? Negative kx? I don't need negative. It's kx. 900 newtons per meter. And it's in millimeters too? Fuck you. 900 newtons per meter times 60 millimeters times, what is it? 1 millimeter is 1 millimeter. How many millimeters to newtons? 1,000? So let's see. 1,000, 1, 2, 3. I think it's like 54 newtons. Let's start with that. Something equals 4. Average statics enjoyer. Okay, my units are all in there, so P equals 45 times, I can't do that one in my head. 45 times 54 divided by 135. 18. Oh. Wait, I just solved it. Wait, that was actually the whole first part of the problem. Wait, that wasn't even that bad. Wait, I was freaking out so much. I thought we had to solve for so much stuff. Oh, because I still have to solve for the bearing forces. But like, this one is easy too. Why don't I just do this one first real quick? I'm just gonna say 2. I'll just put it over here, 2. D equals P min over 2. So then we do moment about BC equals 0 equals MP minus MS plus MB, or D, sorry, equals 0. Same moment convention. Okay, my mic just disconnected and reconnected randomly. Thank you. Same moment convention. So we have MP plus MD equals MS. So you have 135 times P plus, how far is D? Still 135. P over 2 equals, yeah, 45 millimeters times 54. Hydrate? Bye? Thanks. Bye. Have a good day. I will hydrate some. Thank you for watering me. I like how I broke my camera there. Wait, and then we just have to do this. What is this? This is so easy. 2/3. 3/2. Newton millimeters. Not true. 45 times 54 Newton millimeters. What is this? It's the same. It's the answer we just got. 18 times 2/3. It's 12. What? That's so easy. Wait, what is the force at D? Wait, yeah, wait, P. Sorry, P is 12. In this case, so P min. So D equals 6 newtons. I mean, that makes sense. They split it evenly. Or not evenly, they split it 2/3 to 1/3. Which is what they did. Crazy how that works. Okay, Now we just have to do bearing forces. We just have to do bearing. Just. Okay, let's pick something that we like. Let's do moment at B in the Z direction. We get rid of all the nasty stuff. Moment about B in the Z direction is going to give us... We'll have the moment about S, convention. This moment about S is going to be positive. And then our Z goes away, all that other stuff goes away, P goes away. So CY, that's going to be negative. This is great. This is actually great. I mean, I have to do like a shit ton of these, but like moment S equals moment CY. Okay, so moment S, the distance between this and this is going to be 165 millimeters times 45 newtons. And then that's going to equal, how far is C away? From, let's see, 55 plus 135, 55 plus 135 plus 165, 355. 355 times C. Y. CY. Is that correct? Yeah, CY. Beautiful. This is serendipitous. I like this one. Can we do these more? 45 divided by 355? Oh, okay, well that's kind of a nasty number, but that's okay. CY equals 20.91 newtons. It's probably asking for the magnitude of the... It says, determine the corresponding magnitudes of the bearing forces which are perpendicular to BC. Oh, well, we just did one of them. Oh my gosh, wait, it's great. We don't even have to do the other stuff. We don't even have to do the other stuff. Oh my god, this is beautiful. They're so kind to us. We don't even want CZ. Who cares about CZ? Wait. No, actually, they're both perpendicular. Fuck. Never mind. Well, yeah, kind of. I actually don't know. Which are perpendicular to BC. They are both perpendicular. Okay, we'll do all of them. I mean, it's not that much worse. I'll do moment AZ. That'll give us, if we do about A at Z, or sorry, CZ, that'll give us BY. So, moment about S. Oh wait, actually, again, sign convention. S is gonna be negative and BY is gonna be positive. Moment BY equals 0. And MS equals moment BY. No one is surprised. How far are we from things? Great question. S is... Wait, I might have goofed it. I'll check that later. S is 135 times 45 equals, and how far is B? 165 plus 135. Yeah, I think I might have accidentally goofed that. 300 times BY. I think 355 is wrong. I think it's 300. Yeah. Maybe this is a better answer. 165 times 45 divided by 300? Probably not. 24.7. That's a little better. 24.75 is actually a really nice number. I like that. And then this one is 135 times 45 divided by 300. 20.25. Oh god, beautiful. 20.25. How gorgeous. How absolutely stunning. Okay. Then we just want to do the moment about B and C with respect to Y. So do a moment about B, Y, and moment about C, Y. Our sign convention here is going to be this way is positive. Alright, so for z, well, we're doing b. Yeah, so cy. Wait. Yeah, z. That's negative. Negative moment cz. And then s is... Oh, we can't do s. We have to do... Oh, shit. We have to do p. Which is... positive, I guess? No, it's also negative. Uh-oh. Okay, I guess I just got the sign wrong. Minus, moment P. Because this is where we don't have D. This is where a D equals 0. So, D equals 0. I'm just gonna change the sign on CZ so that I don't have to goof it. Because yeah, then that one would be positive, that one would be negative. That one is positive. Okay, so M, I mean, they should equal each other. So our MP is gonna be how far away from shit? Oh, wait, whoa. What were we taking the moment about? We're taking the moment about B. Why? That is 0. That bearing shouldn't take that load. Well, it would take it if there was D. But our D is 0. So CZ has to equal 0 in that case? That feels weird. Am I missing anything else? No, because these all go away. This one is perpendicular, that one's perpendicular. These are the only two over here. When D is pushing up, this one will have to like push down, I think. But no, because P gets yeeted. P is not in here. This is moment D. And moment D equals 0. This is 0. MCZ equals 0. For P min second. That is strange. That is kind of weird. That is kind of weird and creepy in a way. Huh. Fascinating. Well, I mean, I guess it kind of makes sense. Like if you don't have any force there, you don't really need to like oppose that. This Z is was in the right direction before though. Because like you're trying to oppose the D going up. Fascinating. Okay, well that's fine. That's easy to do then at least. Okay, MCY will use the same sign convention. And we'll say in this case our BY. Nope, I lied. BZ is going to be positive. And our P is going to be negative. Good. I'm guessing well. Please put a moment there, Damie. Moment P. So MBZ equals MP. How far is P away from this? A lot of far away. Was that 300 millimeters? I'd rather flip these. My tablet turned off. No, it's fine. What did I calculate P to be? 18 newtons, and then equals equals how far is BZ away? Same distance, 300. Oh, it's just 18. This is so weird. Isn't that wild? That's actually kind of crazy. So BZ equals 18 newtons as well. Damn. I mean, wow. If D existed, then we would do, you know, calculations for this one, and this one would be less. Because then P would be 12, and so this would be 12, and this one would probably be... This one would be 6. I'm learning. I'm learning with portals. I wonder if you guys can hear my roommates playing Mario Kart and yelling loudly. I love them. I love my roommates. Okay, I think I just have one more to do. I think I have one more. I have not planned this one out. Oh, fuck. Yeah, I do have one. There's an optional problem. But it's optional. I'm not going to do the optional problem tonight. Okay, guys, we got this. This is. I gotta do the free body diagram for this, so we get to do a free body diagram together. Although I will say, we are very on schedule for like how many problems I've done. It's good. It's good. I allotted time well. Okay. Oh, this looks so complicated. Okay. As part of a check on its design, a lower A arm, part of an automobile suspension, is supported by bearings at A and B and subjected to a pair of 900 Newton forces at C and D. The suspension spring, not shown for clarity, exerts a force S at E as shown, where E is in the plane ABCD. Sure, you don't really need 4 points to make a plane, but go off. Determine the magnitude Fs of the spring force and the magnitudes Fa and Fb of the bearing forces at A and B, which are perpendicular to the hinge axis A and B. All right. They kind of started the free body diagram for us, not gonna lie. A little bit, but we gotta do it ourselves because we are working class cat boys. And we have to do the time. Okay, this will be I, this will be J. Let's chunk in some places. This will be B. We'll make this A. I'm just gonna have it like come down like this. And then this. You know, I'm an artist. This does not necessarily need artistry. We're gonna have this, and then this. We got like a plate here, and then just like little donkers. It doesn't even really matter where these donkers are, but this is D, and this is C. Okay, so we got our little duder here. We'll give it a little volume. Why not? I feel a little fancy. I feel a little kind. There we go. A little volume. Alright, let's draw some forces. What the hell is that? That is a hole, but we don't care about the hole. We're going to just put this force here. So this one is going to be one unknown, because they do give us an angle. 15. Squished in there, but don't look at me. Okay, so unknown count. The sun is directly shining into my eyes, by the way. It's reflecting off a window into my eyes. I don't know how many unknowns we have yet, but we're counting. So we want Fs. This is a want. We have Fs. We know that there are bearings at A and B. So those bearings are going to stop the thing from flying the fuck out. So they're probably going to go down here. So this is a Z. And we'll do one over here too. A BZ. We're going to put these in here. This is, I'm just going to say FD, and this one is FC. And we also need one to stop it from moving this way. So I'm going to say both of these are going this way. Probably. Because, I don't know, we have no other forces in that direction. This will be A, Y, and BY. A little hard to see. Sun is still directly in my eyes. Okay. Oh, I can block it if I lean forward really far. All right. What are we doing? What are we doing? What are we doing? All right. So we got our free body diagram. We have 1, 2, 3, 4, 5 unknowns. We like that. That's lower than 6. So FS, AZ, AY, BZ, BY. Those are unknowns right there, under my big head. All right. So, where do we start? Well, let's see. If we take a moment about... let's take a moment about AB. Because that gives us FS and FD and FC, and we know FD and FC. I'm going to put little check marks next to them, actually. We know this and we know this. I'm going to say the strat is to moment about AB. MAB, if you will, equals 0. That's going to give us FS, and then we'll go from there. Because every time I do more than one equation, I keep using the wrong ones, so let's just do one, and we'll go from there. Okay, sign convention in the positive I direction is going to be our positive. Again, I'm feeling scalars. There's a lot of perpendicular distances here. We are given a shit ton of perpendicular distances. Let's use them. Why not? So, MIB equals 0. This is going to equal... I'm kind of feeling actually writing it like, not like that. I'm kind of feeling writing it like this. So, these ones are going to make it rotate up, which means that they're positive. So we have positive, we have moment D plus moment C. And Fs is going to make it rotate negative, minus moment Fs. I like it. So now the thing about moment Fs is... it should be okay. I think it's okay, because we don't actually need to define... its perpendicular distance is going to be kind of weird. We might need to use vectors, but let's just move through it right now. So for here, 190 plus 170, 360. Okay, so 360 millimeters times 900. I'm just gonna say times 2. Equals, or no, I shouldn't do that first. Look at me plugging in values. I'm getting so excited. 2 cannot do that. MFS, nope, I lied. I'm gonna put this on this side. Plus MC equals MFS. And then we'll say 2 times 3, what did I say, 360? Yeah. Times 900 newtons. I don't know why I didn't put millimeters here. Equals MFS. Now, so MFS, we need the perpendicular distance from it to this plane here. And you know what? Because these other two are so nice, I don't mind drawing a triangle. And also because MFS is in a plane that's like perpendicular to it. So this is FS, right? So the perpendicular distance to how do I draw this? Okay, so this is FS. Out here. This is 170 millimeters. And this is some X. We don't know that. What we want is... this is like A. We're looking at A in our view. What do we want? We want like this. Do I have any information that can tell me about this? This is 15. Oh, for sure, for sure. We know that's 15. No, we don't. I lied. That's not 15. That is 90 minus 15. Which is what? 90 minus 15. I should know that. 75. Doy. So this is 75. This is 15. This is 15. Okay, we can get that. Because we'll just do a little sine. We'll just do a little sine cosine. You know what I'm saying? Oh, you know. Yeah, who care? So 170 is our hypotenuse. So I don't know. Let's just pick for fun. What's the triangle I like more? I like 75. So because it's our normal like vector direction. Because I just tilt my head and look at it like it would be in a unit triangle, right? 75. With that as the hypotenuse. So in our case, sine of 75 equals, equals x over 170. That's not x. This is x. My professor's gonna be like, why did you do this to yourself? You could have just, whatever. Do I have my shit in radians? Probably not. Let's see. Sine of 75 degrees. Sine of 75 degrees. Can you just like, plug in? Okay, perfect. 0 point something 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 times 170. 164. That makes sense. 164.207. That's fine. I'm okay with that. I'm just gonna say over 164.207 equals fs. Is that kind of scuffed? A little scuffed. But it's okay, because I'm going to use the unrounded number. I'm going to try to use the unrounded number. Okay, so we're going to do, what is that? 2 times 360 times 900, which is huge, divided by this number that I just did. Okay, I guess I can't copy and paste it. Unfortunately, that is a very large number. I mean, kind of not, I guess. No, I guess it kind of makes sense, because it's, a lot of it is, it's kind of scuffed. There's that 3.946 kilonewtons. Are we in kilonewtons? Wait. Things are in millimeters. It doesn't matter. It's all in millimeters. Okay, let's see if he gives me this thing. Then I might be able to figure it out if I'm right or completely wrong. Oh, he just doesn't give a selective answer for this question. He just forgore, or he didn't care. Okay, well, that's fine. Alright, so we got those. That's fine. Magnitudes of FA, which are perpendicular to the hinge axis, AB. Okay, they probably want us to do both parts, and then, like... maybe magnitude of the whole thing? I should probably take the magnitude of the whole thing for those other ones. Because saying FA and FB really imply, like, that they don't just want a component. They want the whole thing. So we gotta do a lot of stuff here. Let's just do what we did before and just say, okay, AZ, BZ, perfect. We're gonna say moment about A. I don't know, do we do Z? Do we do Y? Let's do Z. That's gonna give us BY. Oh, that's so beautiful. Wait. Huh? Oh no, FSY. Whew! Equals, okay, so sign convention is up. I got really scared because I was like, it's equal to 0. Oh no, but then I was like, FSX. Or FSY. Okay. Alright, so... in this case, that's going to make it rotate positively, dy, so moment by, and that one's going to make it rotate negatively, so moment minus moment f, s, y. Oh no, now I need the perpendicular distance of... Oh no, wait, this is so bad. Oh wait, they gave me the answer right here. Oh, we got it, gamers! We got it! 3 sig figs! That's right! Oh my gosh, wait, that's right. Okay, now the question of do I want to, do I continue down the based scalar path, or do I submit to using vectors? I only say base scalar path because it's so much faster. It's so much faster if it's just simple stuff. But then fucking FS... Wait, no. It's still based scalars because it's an X. So the thing is just it's just gonna be, what is that, 300 away? We don't have to worry. We don't have to worry, gamers. We're winning. We're winning so hard at everything. Wait, I wonder. No, I did the moment about AB, so I needed to do that, actually. Oh my god. Oh, that's beautiful. Never mind. I never doubted you, based scalar approach. What is with this song just not loading? I still, my CPU count's not dropped or anything. Huh. This song's not loading. Weird. Okay. So how far is B away from A? Sorry, Y away from A. That's 420. $300. 3.394046 times this is 75. I need cosine 75. Oh. Oh. Okay, so 300 times 3946 divided by 420, and then this answer times cosine. Am I in degrees? God damn it, I always forget to check if I'm in degrees. I think I'm in degrees now. Cosine of 75. It should be less. A lot less, yeah. Equals 794.5 newtons. I like that. I like that answer. That makes sense. Oh, I like these bearing ones where you can, like, just knock out the stuff. That's pretty cool. I like that. Let's do AY. So if we do AY, that's going to knock out... It's just going to be our Z. Although it is also going to be our FC. So we'll have to do F... Okay. So we'll do BZ. Sign convention first, sorry. So BZ is going to be negative. Negative moment BZ. FC is going to be positive. And FS is going to be negative. Minus F, a moment C, I guess, is just the best way to put it. Yeah. So moment BZ equals if I move this over here, that's positive, positive. They're both minus. Minus moment FSZ. Uh-oh. I goofed it. I goofed it. Is it supposed to be going up? That's crazy. I guess I'll just... Yeah, they shouldn't all be negative, huh? Wait, no, they aren't all negative. FC is positive. Or moment C is positive, so this is positive. And that should be bigger than the other one. Silly Damie. No, it's not. It's this way, and that's probably correct, yeah. Okay, so the distance of this to this is the same. That's 420. Yeah. equals, and then moment FSZ is still going to be 300, I think. Right, 3946 sine 75 minus, and then the distance of this is a little different. That's 180. 180 times 900. I think. $300 times 3946. This times sine 75 equals a very large number times 180. Oh, divided by 420. Okay. BZ equals 2336.8. I don't need that. 2337 newtons. And then if I square these, okay. I'm so nervous. This squared plus 729.5 squared equals this massive number, and then just this square root of answer, 2448. 2448 newtons. 2448 is this. Let's go! Let's go! Yes! Let's go! Let's go! Oh my gosh. Okay. Then I just have to grind out the other one. Oh my gosh, that's so nice to know. I actually know what I'm doing. Yay. That's awesome. That's so awesome. Yay. Okay, let's just crank out these other two ones. I say crank out. They're not going to be super simple. I mean, they're not trivial, I guess. I want to say they are. Okay, BZ. So that's going to be... We have AY and F. So AY is going to... So our positive is still going to be our positive convention. No, I lied. Positive up here. So AY is going to be negative, and then FS is going to be also negative? Whoa. I goofed it, I guess. Oh, no. No, it's positive. FS is positive. Minus moment AY plus moment FS Y. I said that like that, right? Yep. Moment AY equals moment FSY. So moment AY is going to be the distance, 450, as always, times AY equals, and I think the moment of FS, it's going to be a little bit different distance. It's going to be, what is that? 120? Yeah, 120. Quick math. 300, 420. And then times... Oh shit. Wait. No, that's right. That's the right distance there. Yeah. I don't know why it gives us that. I don't know why it gives us the 170. Maybe just because it needs to be dimensioned. But it's not I don't know. Who knows? Statics, man, it's crazy. 120 times 3.946 times cosine 75. Now we just have to crunch that. 120 times 3.946 by 450. this times cosine. Not that. 272. 0.3. So excited. Okay, y. I don't like this one as much, but it's okay. Because we have to do the other things. We have to do these doofuses. We have to do FD in here. Oh man, I just dropped my pen. Okay. So we're gonna have FS. Right, FS is gonna push it positive. Right, so MFSZ. I'll add to that. And then what have we got? BZ. Nope. AZ. That's going to be also positive. And then we're going to have that one, which moment D. Okay, so moment AZ equals moment D minus moment FSZ, which it might yield us we figured out the wrong direction, because I don't know if that is bigger or smaller, but we'll find out. Okay, how far away is Z? It's gonna be like 420, it's 420. Wait, 450? Hey. Did I say 420 or 450? I said 450. Grr, it's wrong. It's 420. I don't know why I wrote 450. This number is even smaller. 420. There we go. And then this... Oh, there we go. No, that's more right. Cosine of 75. 291. That makes any sense. 0.8. And then... What was I doing? 420 times AZ equals, right, so how far is this force from there? Also 420. Wait. Oh, because that one was in more. Times, did I find MD? Oh, lol. 900. And then how far is this from here? That's our 120 again. 120 times 3 sine 75. Okay. To the gods of statics, please be right. I shouldn't worry about it right now because I haven't even gotten to the point where it could be wrong, but we're gonna worry anyway. 120 times 3946 times sine 75 is a cos or sine? Sine. What's that? Divided by 420, it's a negative number, bad, but that's okay. AZ equals, I'll just fix it, 189. Plus, minus, plus, 189.0. 189 newtons. And then I'll just go and change AZ. He doesn't really care if we change it or not, but like, it's just easier for me to... That's fascinating. I mean, I guess it kind of makes sense, because there's like more force down over here, so like... I don't know if that total is going to be right. These don't look high enough to be that. We might take the L. 291.8 squared plus 189 squared equals that, and then square root of answer 347? I don't even know how we got that high. 347.6 newtons. FA. That was not, what did I say, 400 something? We'll have to come back to that one. But another day. Well, not another day, because I have to finish grinding this out. This one is done. This one is not done. It's just me writing a giant sigh. This one is done. No, that was the weird... This is the weird one. This one is also not done. The other one is done, though. That one's actually weird. I might have to redo that one. This one is correct. And this one is like... Maybe I have to go back and fix it. But I'm probably going to do some stats before then. And also eat dinner. Lol. Anyway. Thank you so much for hanging out, people. We had some epic wins on the problems. Not gonna lie. There's some pretty epic ones. I feel these are pretty good. I feel like by the end of it, like we were kind of cooking there a little bit. Not gonna lie. But yeah, I will see you guys later. I'm gonna stream because I have a statistics data analysis midterm. Stay winning, so real. Data analysis midterm tomorrow, which I also have to study for. Lol. But I put off this problem set because I wanted to stream it and I couldn't stream yesterday. So normally I wouldn't put off problem sets, but stream calls. Yeah, so midterm, and then I'm like kind of chilled out. I have to like do a 3D print probably like right now. I probably should start that print right now. Oops. I have to design the... You know what? I don't have to design the end cap before I print the main piece. I didn't even think about that. Anyway. None of that matters. I'll be back. We'll probably be doing... we're probably not going to do statistics. Probably not statistics next time. Probably, I don't know. Probably statics, if I'm being real. I know I'm doing a lot of statics, but like... A lot of my work is statics. Maybe we'll do some data analysis. Like memo stuff, not statistics stuff. Because I'm not going to do any statistics work until like closer to the next midterm, I'm sorry. Sorry, Professor. I have other classes. But yeah. Yeah, so I'll be back probably on the weekend. My favorite song. I specifically put this one in, even though it's like... Oh, it's just the credits. That's funny. Well, it's perfect, it's the credits. Okay, I'll see you guys this weekend. Have a great day. Stay hydrated. Stay safe. Sleep well. And have a goodbye. Have a goodbye. Goodbye, everybody.